Hi, today we're going to be learning about matrix multiplication. We just worked with some matrix addition and subtraction, so now we're moving right on to multiplication. We're going to do some multiplying by scalars, which is just a real number, and also a matrix by multiplied by another whole matrix. So that word scalar is probably new to you. All it means is we're multiplying by a number, like 4. A real number. Alright, so if we look at this example here, to multiply a matrix by a scalar, all we're doing is taking that scalar C and multiplying it by whatever you have for a matrix. So in this example, we have the matrix D, and we're going to multiply D by 2. So all we're going to do is multiply every element of D by 2. So the first one, 1 times 2 is 2, 0 times 2 is 0, 0 times 2 is 0, and 1 times 2 is 2. So that's all we're doing here. Super simple. We just multiply by 2 for every element. Okay. So here what we're going to do when we are using a matrix like C and multiplying by 1/4, we take 1/4 times every element in D here. Oh, C I mean, excuse me. So we're going to do 1/4 times 3, which is 3/4. 1/4 times -3, which is -3/4. 1/4 times -1, which is -1/4. 1/4 times 2 is 1/2. 1/4 times -2 is -1/2, and 1/4 of 4 is just 1. So, like I said, very straightforward as far as how we multiply by a scalar. You might see some like number 7, 5 times D minus A. For that one, all we need to do is 5 times the matrix D. So it would be 5, and then 0, and then 0, and then 5. And then we're going to subtract from whatever we got there, 5, 0, 0, 5, by A. So we'll subtract A from that matrix 5 times D. We're not going to run through one of those. So scalar multiplication is, we have the closure property, and all that means is if you multiply a scalar by a matrix, you get another matrix. The associative property just tells me if I multiply C times D, so like 2 times 3, and then multiply that 6 by matrix A, it's the same thing as multiplying 3 times the matrix A and then multiplying that again by 2. We can use the distributive property. We could add A and B and multiply by C, or we could multiply C by A and add it to C times B. The next one is just distributive property the other way. Same thing. Multiplicative identity just tells me if I multiply that matrix by the scalar 1, we get the matrix that we started with. And the multiplicative property of 0 is if we multiply that matrix by 0, we get 0. Okay, for this next one, we are going to have working through solving a matrix equation. So we're going to solve for that whatever matrix we're looking for there. So for number 10, we have 2 times the matrix 0, 1, 3, -4. I'm just kind of moving this back around here. So what we're going to do is multiply first. 2 times 0 to get 0. 2 times 1 to get 2. 2 times 3 to get 6. And 2 times -4 to get -8. Once we've done that, we are going to still need to subtract that 3x, there we go, in order to find out what that matrix X is. So if we want to solve for X, we're going to continue to do that as if we were solving an equation that we've worked with in the past using inverse operations. So first I multiplied to kind of like get rid of that scalar in front. And then we're going to subtract this matrix from both sides. And I'll show you what that looks like. We're going to subtract from the left, subtract from the right. When I subtract from the left, it actually cancels out, and we're just left with this negative 3x here. When I subtract from the right, I just do it as I've done in the past, and I get 9 minus 0, oopsie, which just gives me 9, and I get negative 6 minus 2, which just gives me negative 8. Let's do that again. There we go. I do 1 minus 6, which gives me 5, and negative 2 minus 8, which gives, or minus a negative 8, which gives me 6. So from there, I still have negative 3x equals that matrix. I need to divide by negative 3, or another way to think of dividing by negative 3 is actually multiplying by negative 1/3. So here, that negative 3 divided by negative 3 cancels out, and we're left with just that matrix X. And negative 1/3 times this matrix, we're going to write X equals that matrix here. Negative 1/3 times 9 is negative 3. Negative 1/3 times negative 8 is just 8/3. Negative 1/3 times negative 5 is just 5/3. And I'm working off of here. Negative 1/3 times 6 is just negative 2. So now we've actually solved for what that matrix X is, and we can check our answers by just plugging in this matrix for X and seeing if 2 times this matrix minus 3 times the one we just found is equal to 9, negative 6, 1, negative 2, that matrix. I'm not actually going to take the time to check it, but you can do that on your homework. Okay, here's where it gets a little bit more complicated. We're actually going to do some matrix multiplication where we multiply a matrix by another matrix, which we can do. We don't need to just have a scalar every time. So here we're multiplying A times B. So we're going to take elements in row 1 of A and multiply it by elements in column 1 of B. So this one's going to look like A, this first element, or here 2, times the first column of B, 0. And 2 times 0 gives me 0. Okay, and then we're going to add, see that, the second column, first row of A, to the first column, second row of B. So I'm going to add negative 1 times 4, or, oops, not negative 1 times 4, sorry. What am I doing? Negative 1 times negative 3, there we go, which is 3. So we're adding 3 here. Okay, the next one, we're going to keep moving forward like this. I'll do that in a different color, in blue. So we're going to move right ahead and continue on with this first row. So 2 times, now we're going to move on to second column, 4. That gives me 8. Then I'm going to do the second column, first row, negative 1 times 1, which we're going to add a negative 1, which is subtracting 1. Okay, we're just moving right along. And then we can see here, once we get down to second row, first column, we're going to multiply just like they did here. 2, 1 times 1, 1 in the second matrix, and then 2, 2 times 2, 1. So we just kind of move right down from the first row, first column, first row, second column, second row, first column, and then we'll do second row, second column, and we've multiplied everything we need to. So we're going to do A, 2, 1 right here. 5 times 0, which is 0. And we're going to add to that 3 times negative 3. So negative 9. And then we've completed this one. Next, we're going to do 5 times, we have not done this column yet. 4. And let me just swap out this color. 5 times 4, that's going to be 20. And add to that 3 times 1, which is 3, so 20 plus 3. And then we just simplify all that addition. So this first one, 0 plus 3, is going to give me 3. 8 minus 1 gives me 7. 0 minus 9 gives me negative 9. And 20 plus 3 is 23. And that's our matrix multiplication. So it's kind of a lot of moving pieces. It's a little bit to follow here. So I want you to pause me and give it a try for number 13. Give about a minute, minute and a half, and then push play and check your answer. Okay, time to check your answer. So here we did 0 times 2 is 0, plus 4 times 5 gives me 20. The next one, we did 0 times negative 1 is 0, plus 4 times 3 gives me 12. And moving on down, we did negative 3 times 2 is negative 6, plus 1 times 5, which is negative 6 plus 5 is negative 1. And then negative 3 times 1 is 3, plus 1 times 3, which is 3 again. 3 plus 3 gives me 6. So you should have had this matrix here. Okay, we can also multiply matrices that don't necessarily match. We just did a 2 by 2 and a 2 by 2. And the reason we can multiply these together, this one here is a 1 by 3, and this one is a 3 by 1. So the two numbers that need to match here in order for this matrix to be able to multiply together are these two. They have to be the same, and then you can multiply them. If they're not the same, it's not going to work out for you. And the matrix that you get will be the last two numbers. So this one we would get a 1 by 1. A 1 by 1 matrix, which is just one number inside your matrix. One row, one column. One number. So that one would just look like 2 times 2 is 4. So we're going to add 4 plus negative 1 times negative 1 is 1. So 4 plus 1. And 6 times 6 is 36. And we're going to add that together as well. So here we have 4 plus 36 is 40 plus 1 is 41. And that's your product. Can we multiply this one together? It is a 1 by 3 again. And this one is a 3 by 2. So do my two numbers match? The end of this one, the columns in this one and the rows in that one need to line up because we're doing column by row. Okay, and so then yes, they do, and your resulting matrix is going to be a 1 by 2 matrix. Okay, this one's exactly the same way. So let's actually try a little bit tougher here. No, I changed my mind. Let's actually work through number 15. So this one, we're going to multiply together, and we're going to get a 1 by 2 matrix with that multiplication. Okay, so we're going to do, starting with this row and this column. So obviously all of these are zeros. So it's going to be 2 times 0 plus negative 1 times 0 plus 6 times 0. So 0 plus 0 plus 0 gives me 0 right here. The next one, we're going to do 2 times 2 going this way, which is 4 plus, so to find this number, 4 plus negative 1 times negative 1, which is 1, and 6 times 6, which is 36 again. Those same values. And so we get 41 right here. So here is our 1 by 2, 1 row, 2 column matrix that results. to tell whether the product exists, we just need to check to make sure that the columns in the first match the rows in the second. So here we have S right here times P. So S is a 2 by 2 matrix, 2 rows, 2 columns. P is also a 2 by 2. So because these two values here, the columns in S and the rows in P match, yes, we can have a multiply these together and we get another 2 by 2 matrix. QS. So Q right here is a 2 row, 1 column, so 2 by 1. S we just did is a 2 by 2. And this one, when we check the 2 in there here, the column and the row, they do not match. So those two, we can't multiply it together because the number of columns in Q does not match the number of rows in S. Let's do one more. PR. So PR here, we have P is a 2 by 2. Ooh. And R, we have a 1 row, 2 column, so 1 by 2. And we can tell already that the columns in the first and the rows in the second do not match. One's a 2, one's a 1. We cannot find a product. The product does not exist for that one either. All right. So that's all we have for today. Here's your assignment, page 777, 1 through 27, 29 through 33. You guys are welcome to get going. Please work on it in class. Anything you don't have done, take home. We're going to turn them in on Friday.